Right. Lastly, I would like to discuss about the applications of fluid antenna system. And here I'm going to discuss about some of the approaches that you can consider in combining fluid antenna system and other emerging technologies. And I believe some of these emerging technologies can be technologies that you are currently working on. So first, I would like to discuss about the FAS+RIS framework. Okay. So RIS is a very popular technology in wireless communication. It's a matter surface that can reflect and also change the phase of the signal. Okay. So how can we combine FAS and RIS together? Well, one of the approaches is that you can actually implement fluid antenna either at the transmitter side or the receiver side or both ends, right? And then you can perform, you can optimize the parts, you can do the beamforming, the power locations, and also the IRS phase shift, right? So this is a very straightforward approach. And if you are interested in this direction, you can have a look at this paper here. Another opening approach is that you can consider matter surface unit with reconfigurable positions, all right? And this can be extremely useful because in practice, the RS phase shifts are actually discrete. So having the ability to reconfigure the positions can actually help to improve the discrete phase shift resolutions, right? Now, in my opinion, another more novel approach is actually treating RRS as artificial scatterers, right? And in this approach, there's no need to optimize the RRS phase shift, and there's no cascaded channel estimation problem and so on. And more importantly, is that the performance of FAS can still be promising. And the reason is because FAS actually favors a rich scattering environment. Okay, so RIS with artificial scatterers can actually provide that environment. As a result, the fluid antenna system, the performance of fluid antenna system can actually flourish. Okay, so these are the three approaches that one can actually consider if you're working on FAS and RIS. Now, next, I would like to talk about next generation multiplexers with FAS and NGMA. So in my opinion, there are two approaches. One is that you can use FAS to enhance existing multiplexers, such as orthogonal multiplexers, non-orthogonal multiplexers, or even rate-splitting multiplexers, and many more. For instance, as shown in this work here, we have actually discovered that FAS with OMA, okay, orthogonal multiplexers, can outperform CAS, traditional antenna system, with NOMA in a multiplexers scenario. So this is quite an interesting findings. Why? Because this implies that a suboptimal scheme in FAS can actually outperform an optimal scheme in TAS. And this is true even when the CSI is not available at the transmitter. So this can actually further bring development to multiplexers, right? New development to multiplexers. Another method to improve the existing multiplexer scheme is that you can orthogonalize, you can use FAS to orthogonalize or correlate the channel. So for example, OMA favors orthogonal channels, NOMA favors strongly correlated channel, and RSME favors something in between. Okay, so you can actually use the unique capability of reconfiguring the position to orthogonalize this channel or to correlate this channel. Now, if you are interested in this approach, you can also have a look at some of this paper here. Now, the second approach is to develop a new form of multiplexers. So, for instance, Professor Kidd has proposed PHAMA, KUMA, and he has also proposed the opportunistic PHAMA, where this concept is to opportunistically exploit PHAMA, right? And if you are interested in this, you can also have a look at this paper here. Nevertheless, there are actually still a lot of room for innovation So if you'd like to develop a new multiple access scheme, you can actually take this approach and you can try to focus on different usage scenario, and that can actually lead to new ideas. Now, FAS can also be employed in non-terrestrial network, for instance, in UAV communication. In particular, you can jointly optimize or reconfigure the large-scale fading and small-scale fading for communication, right? So for small-scale fading, you can optimize the ports, power location, and beamforming. Okay. Now, in addition to these small positions, you can also optimize the large-scale fading. For example, the UAV 3D location or the UAV trajectory. But it's worth noting that the changes of these locations or the ports can actually vary at different time scale. So, for example, the UAV might actually need a few seconds in order for the location or the trajectory to be substantially different, right? But for the ports, it actually changes after a few milliseconds and so forth. And therefore, one should actually take note of this variation. Now, FAS can also be used to improve physical layer security, PLS. Okay, so again, you can optimize the port, the beamforming, the power locations, and so on. But in addition to those, you can also exploit this pharma concept. Okay, the difference is that instead of interference, you actually have jamming signal. So the interference signal is actually being replaced by the jamming signal. Then you can also apply coding. So this coding can help the jamming signal to appear as noise to the eavesdropper, but as an information to the legitimate user. So what's the unique benefit of FAS? Why should we employ FAS in physical layer security? Now, one of the advantage is that the security rate can not only outperform traditional antenna system, but also maximum ratio combining. And this is the sort of like traditional multiple antenna system, okay? And that's why you might actually want to use FAS in PLS. Now, if you are interested in physical layer security, you can also have a look at some of this paper here. Another very popular topic is AI, right? So we have AI and power FAS as well. So in this topic, I see two approaches. One is that you can actually optimize FAS using AI. For example, you can estimate the channel and reconstruct the channel using recurrent neural network or convolution neural network, autoencoder, and so on. In addition to that, you can actually use reinforcement learning to optimize the ports, the power location, the beamformings, and so forth. So these are one of the approaches. Another approaches is that you can actually optimize AI using FAS. And this is because FAS generally provides a better communication as compared to traditional system. As a result, the mean square error or the convergence rates of the AI applications can actually be improved. Therefore, you might want to consider FAS. And then we also have other technologies. For example, we need to develop green FAS, right? Because we want to have some environmental friendly system to save the world. So in this context, one can actually focus on energy efficient scheme, wireless power communication networks, and simultaneous wireless information and power transfer. Okay. The uniqueness here is that the ports for optimizing the information transfer may not be the ports for optimizing the energy transfer. So what this means is that, okay, in traditional antenna system, we cannot choose the ports. So that's a limitation. FAS can actually introduce a new degree of freedom, and that is having the ability to reconfigure the ports or the location of the antennas. However, it's important to note that the ports for optimal information transfer may not be equivalent to the ports for optimal energy transfer. So that is the discovery that some of the colleagues have found. And if you are interested in this, you can also have a look at some of this paper here. In addition, FAS can also be employed for ISAC, integrated sensing and communication. In particular, it can be used to improve the sensing and communication trade-off. Now, how to achieve this is that one can actually use a point or location where there's a high channel correlation between the sensing and communication operations. Furthermore, FAS can also be used to improve the privacy of the sensing target. For example, if the sensing target is equipped with a fluid antenna, then it can actually choose a location or a pod to avoid being sensed, and that can actually improve the privacy. However, this would also create new scenario for ISAC, and therefore there are actually a lot of things to be explored here, right? So are there any other interesting direction? The answer to this is yes. So for example, you can also develop system models that are compliant with the principles of physics, antenna, and circuit theories. You can explore the electromagnetic or information theoretic performance limit for FAS. Furthermore, you can develop optimization theories and algorithms that are not only advanced, but also insightful. Right? In the previous few slides, I have mentioned that the AI-assisted algorithms can be very helpful. However, we have been focusing on the physical layer and also the medium access layer. Nevertheless, AI is extremely useful for management and protocol as well. Therefore, I believe that it's also time for us to look at cross-layer. Okay. Then in this presentation, I believe that you have learned how to perform the channel estimation and reconstruction. However, it's also very important to analyze the channel estimation and reconstruction error. Now, given the uniqueness of having the ability to reconfigure the positions of the antennas, it is also possible to develop new coding and modulation schemes. So these techniques here can actually complement each other, and therefore new ideas can actually be developed. Then I've also mentioned that FAS can be employed for ISAC, right? However, it's also possible to develop or to jointly consider communication, catching, sensing, and computing design. Early in this presentation, I have also mentioned that FAS is closely related to holographic MIMO system, as well as other next generation reconfigurable antenna system. So it's also possible to analyze the interrelationship between these systems, right? After that, I've mentioned that FAS can also be employed in non-terrestrial network, in particular the UAV communication. However, in that case, the UAV can actually be controlled by the operators, right? But in vehicular to vehicular or vehicular to everything scenarios, this vehicle cannot actually be controlled by the operators. So how to employ FAS in this kind of scenario is also very interesting, right? In addition, we also need more experimental results. So these are some of the interesting directions that one can probably explore. And of course, there are many more. So from the objective of this talk, I hope that you are able to grasp this conclusion. First is that FAS is the next generation reconfigurable antenna technology for wireless communication. Furthermore, it can exploit the position, shape, and other antenna properties to improve the wireless communication performance. And as I've just mentioned or discussed, FAS can also be applied with other emerging technologies to meet the wireless communication demand in different usage scenarios. Right, so I hope that you are able to grasp this conclusion here. However, it's worth noting that FAS is still at its early stage of research. Therefore, I believe that there are many more works to be done. Okay. Now, last but not least, I would like to share a good news. That is the IEEE Journal on Selected Area in Communication. That's IEEE JSAC. It has a special issue on fluid antenna system and other next generation reconfigurable antenna system for wireless communications. Okay, so we actually warmly invite everyone to submit research papers that are related to this topic, to this special issue. Okay, the manuscript submission deadline is 15 February 2025. And we look forward to your contributions. And with that, I would like to end my sharing. And again, thank you for your time and attention in this presentation. If you'd like to learn more about FAS, you can also visit www.ee.ucl.ac.uk fluid-antenna-system. In addition, if you'd like to know more about the technical details, for example, how to model the channels, how to perform channel estimation, how to optimize the system, what are some of the hardware designs, or you like to look at the problems at a fundamental level, you can also have a look at this tutorial paper here. It's a very comprehensive tutorial paper, which is about 50 pages. So I believe that this information can be very helpful to you if you like to work on this direction. Okay, so if you have any questions or if you'd like to contact me, feel free to email me. My email address is a.new@ucl.ac.uk, and I will be very happy to receive your email, and I would love to assist you as much as I could, right? So that's it for my video, and thank you. See you again.